Cool. Okay, so today we said we'll discuss about exploratory data analysis. But let's start with our usual quote of the day. So we're taking a quote from a motivational speaker and author, Zig Ziglar. He said, "It is not what happens to you that determines how far you go in life. It is what you do with what happens to you." So I just want to rephrase that to say it's not what we teach in class that matters about how far you go in AI and machine learning, but it's what you do with what is taught in the class. It is what you do with the time that you're spending, whether you're going to continue investing your time in this. That's what matters in the long run. I didn't think of saying this, but I just remembered now when I started learning Python, data analysis on Udemy, on Coursera, I was just doing it by myself. That was doing a school program here then. My school program was not related to that, but I just had a passion for it. So I was learning it alongside going to school and all that. It took about, well, there's some years where I didn't learn much. I was just, I think it started from like 2016, 2017 now. But I think it took about three years or thereabout before I got my first real job as a data scientist. But during those 3 years, 4 years, I was working on projects within school with big companies actually, though the pay wasn't much, right? So the general idea why I just shared that is I was learning, but it took some years before it actually paid off. So it's not what we do maybe in these 3 months. Yes, the time can be very short for many of you. Just to also share quickly, as we have some time now, that I think I did a mentorship program with someone, one-on-one mentorship for like 4 months. And after that 4 months mentorship, after I completed my mentorship, the guy reviewed my resume, reviewed my LinkedIn. Then that's when I got my first job within after a month or 2 or so. Right. So I've been learning on my own, but then I just kept on doing that till the breakthrough. Right. So it's what you do with what we are learning that will eventually make the difference. So let's keep on. So today we're going to touch on these different areas you can see here. Framing a data science problem, we'll talk about that quickly. We'll talk about different aspects of exploratory data analysis, data understanding with pandas, visualizing your data, some data cleaning, getting insights from your data, and some feature engineering also. And we're going to do that on a Python notebook, actually. So framing a data science problem. Now, it's important to understand the steps in solving a data science or machine learning problem. Some people call it data science because you use data. Some people call it machine learning because you use machine learning models. The names can change depending on what company you're discussing with. So there's a standard, cross-industry standard that was developed some time ago. So it's called cross-industry standard processes for data mining. So it's just to create some standards, standards for how you interact with industry partners on solving their data science or machine learning problem, right? It's mainly, but generally when you're solving a machine learning problem, there are mainly 6 steps you will encounter. One is you're going to do some kind of business understanding. So I remember when I was working with one retail company, they had a large chain of businesses. They had healthcare and team, people like a pharmacy store or something. So those people within that pharmacy group, they would come to the healthcare data science team and they explain their problems to us. Then we go to the data to start finding how to solve that problem for them. So business understanding is you're going to engage with business partners to understand their problem. Let's say within Nigeria now, for example, you get a job with Unilever, for example, and Unilever is having some constraints about, okay, they do not know how to forecast the demand that Nigerians would maybe the I don't know what's Unilever product now. Let's say toothpaste. The toothpaste that Nigeria require, let's say in this month of April or March, right? So you would now discuss with them and say, okay, what kind of data do you have? Have you been collecting data for the past few years? We can use that to build a time series model or something. Are there other features? So business understanding is basically to discuss with business partners to understand clearly what their problem is. Then when you after that you start collecting data, so data collection and data understanding. You want to spend some time to understand different features of the business, the different data that they have, how you can connect different tables. That's why sometimes it's important as data scientists or machine learning engineers or AI, wherever you find yourself, it's important to understand how to interact with databases. So sometimes it's good to learn SQL. Though if we have some time, we touch on some SQL at the end of this, but it's not paramount. It's not an important part of understanding machine learning in general. But during practice, even when you are going for interviews in some roles, because you're going to interact with data, they're going to ask if you know SQL. SQL is just structured query language for organizing structured data and pulling data from a database. Then after you understand your data, know how to connect different tables, then you're going to start preparing your data, which we will spend some time today. So what we are looking at now, we are assuming we have some business understanding, we have some data understanding, not fully yet, but now so I'm going to look at the data as we're preparing the data, we'll get more understanding. And this is the phrase of exploratory data analysis. So data understanding and data preparation is part of exploratory data analysis. Then once you understand the data, then you're going to know, okay, what kind of models can you use to solve this problem? So the modeling can be supervised learning, unsupervised learning, recommender systems, time series forecasting, different approaches like this for you to apply a model to solve the problem. Let's say, for example, GoTV comes to you and say, people are not watching their programs too much, but they have a lot of movies, or maybe it's Netflix. They have a lot of movies on the platform. They feel like Nigerians are not watching the program so much. What can you do for us? Then you would interact with Next and say, okay, what kind of data do you have? You have some data of past movies. You have some data on how people interact with the system to like maybe what movie did they just watch now, or how much time did they spend on that movie. So when you get those data and you prepare them, then you can start looking at, okay, maybe build a recommender system based on that. So the recommender system for that movie platform can be that when people turn on their TV, they're going to see the previous movie they've watched. Maybe they didn't finish that movie. Then similar movies to that they can also check, right? I know YouTube does that, for example, where if you just go on YouTube, you would see something relevant to you. So YouTube will show you some, like me, because I watch a lot of Nigerian music or news and all that. They will always recommend Nigerian news to you once you go on the platform, right? And even Netflix does that. So that's modeling. Then when you select a model for that kind of problem, you're going to now find a way to evaluate it. So evaluating the problem, the model means you're going to use some kind of error metrics to say, okay, is this model I'm selecting, is it going to do well in practice? Is it going to give me, let's say, 80% accuracy, or is it going to give me 90% accuracy? So you're going to have to evaluate the model, and then you're going to deploy that. Deployment now means, okay, the model is now in practice and the company is using that to recommend real time to customers, or using that to forecast their time series, and then use that to improve their business in general, right? Because if you don't evaluate your model properly, let's say you use a 60% accurate model compared to a 90% accurate model. 60% accuracy, for example, may give, let's say Unilever, it may give them, let's say 100 million naira profit. But if you just increase 100 million by 30%, that would have been 130 million naira profit. So it means that if you improve the accuracy of the model, it's not just the accuracy, it's not just numbers you're looking at, you're also looking at potential income that the company could get, or potential cost savings that the company could get from applying your model, right? Because you're going to deploy that model and they're going to use it in real time. Okay, so any questions for these different steps in understanding the data science or machine learning problem? Any questions or comments?
No questions, sir.
Okay. Okay, so let's move. Okay. Okay, so we touched on this last time that we're going to talk about exploratory data analysis. Exploratory data analysis is basically gaining insight from your data, understanding the underlying structure. You've connected different tables now, so you're trying to detect outliers from that those tables, and think about what kind of models can you apply, understanding the underlying assumptions within your data and all of that. So this is what exploratory data analysis is about. So in exploratory data analysis, you're going to look at descriptive statistics of your data, visualize your data, do some correlation analysis to understand how your data moves together or apart from each other. Then sometimes you have to do some dimensionality reduction. That's reducing the size of your dimensions. Then also you have to handle some missing data. Yes, Ifeanyi, you raise your hand.
Yes, sir. Please, I want to say something, sir. This this model, we've been talking about this model for a long time now, and I'm suggesting if it will be possible for us to build just one model, and then we see example of how the model works, and then before we can now proceed to some of those the things, the language of this machine learning, because you know, when you talk about different models, and then at a point to begin to just live in our imagination about the model, but we have not really seen the model in action, and then how it operates.
Okay. Okay. All right. Yeah, it's noted. Okay, it's noted. But let me respond to that also, that you have to learning is step by step. If you miss one thing, you will just, if you, I just start to give you models now, you may run from machine learning, you may run from the class. So it's good to go step by step. So far, we looked at Python basics. Now today we'll do some exploratory data analysis, right? Before you build models, you just saw now that we just said that there are different steps here to be taken. So we're going to dwell on data preparation before we get to modeling. You don't just, that's another thing about the whole machine learning thing. There's some need for patience even on the job, right? Though there are companies where they would really rush you to get results, especially for startups, right? But usually you have to spend some time to understand your data. I think I mentioned one time, whether last week or the previous week, that, or the week before that, that there was one time where I spent like 4 months working on data, just 4 months, just understanding the data for the business before even going to any form of modeling. So it's we have some time. We're almost at the model stage. From next week, we'll touch on models. But also within your groups, we want to start the project discussions from next week. So you can start touching on models also from that. Right. So it's gradually, I understand the
All right, sir. Thank you, sir.
Yes, I understand. I almost jumped one time, but it was too fast. So yeah. All right. So we talked about this handling of missing data. We've talked about this last week also, about different Python packages that you can use for exploratory data analysis. So now we'll go into the exploratory data analysis. Okay, so I'm going to stop sharing. I think I'll share the screen. You need to share the appropriate screen here. Just give me 1 minute. Okay. Okay, so we're going to use Google Colab for this activity. If you have a Google Colab, you can follow the class. You can follow the class with this. I'll share this data. I don't know if the size is okay, just a few. So I'll share this data on the WhatsApp group. If you have WhatsApp on your system, then you can follow the class with this data. So you can either open your data on, what do you call it now? You can open your data on your Visual Studio Code or just here on Google Colab. So our data is used cars. So I've uploaded it from here. You can upload your data from here, used cars. So I uploaded the data. There's also another one on clean employment, but let's use used cars. So that's so the first thing you do for your data analysis, we talked about how there are different Python packages that you can use. Pandas is the major package in Python for data analysis. Then you have Matplotlib for visualizations. Seaborn is mainly for fine visualizations, though it builds on top of Matplotlib. So you have to import Matplotlib when you use Seaborn. Then NumPy is for arrays, some mathematical operation. We talked about that last week. So you see how we are building on top of what we did before to help some people understand. I remember the last time we just came and put pd.readcsv, the whole class one scatter. So yeah. So now, first thing we said that with pandas, you can read a wide range of data. So with pandas, we can load CSVs with this method. So it is a method of the pandas package here. It's called read_CSV. So if you use read_CSV, you specify the name of the file you're trying to read, which is we're trying to read usecars.csv. So we're going to load usecars into the memory, you can call it usecars or you can call it data frame. For the sake of brevity, just simplicity, I'm calling it DF, data frame. So sometimes you can specify the index column or you can leave that blank. I noticed for this file though, if I leave it blank, it may add that on that column. So you have to specify the index column as the first column. Yeah, that's why we have this. Okay, so if you put data frame, we'll load that. I just want to go through the code step by step. If you are running it on your system, follow. If you are not running it, also follow and ask some questions so you understand when you rewatch the video and run it yourself. So in pandas, you can look at the first few rows here. For the use case, you can look at the first few rows, df.head. If we do df.head, it shows us the first 5 rows. If you want to look at more, you can say df.head, show me 10 rows. It will show you the first 10 rows. So at a glance, you can get a picture of what your data is about. Location, give some kind of car products, location, the year of the car was made, the kilometers this car has been driven for type, and all of these different columns. You can also do df.tail to look at the last 5 rows in the data, last 5 rows here. You can also do last 10 or last 7 rows, whatever. Okay, so we see that we can, so you're just getting, so the first stage that you're just trying to get a good understanding of your data, just basics. So you can look at, okay, how many rows do we even have and how many columns? So if you look at, you can use df.shape. Now, I'll just mention this again. I think we talked about it in the last class. Don't bother about knowing whether to put circle here or not put. Just practice. As you keep practicing, you will learn and understand how to use Python better. You may not even have to remember this, but once you start practicing it, will just become a part of you. Okay. So df.shape would give us the shape and the number of columns. I just want to also show, let me see. Let me put code up here. So let's look at some more things about our data. We can look at DF data types. Data types. So it's showing us for each of the columns, it's showing the data types. So we have a name column, which gives us the name of the car. Data type is object. We have a location column, the data type is object. Object here just means string. That's it, it's a text, right? In pandas, it calls text objects. Then you also have floats. We talked about data types before. So you see how we are building on top of what we already learned. We talked about integers and floats. So this year is an the years are integers here. Surprisingly, the kilometers driven are also yeah, the kilometers are integers too. Then price is floats here and all. This new price is an object, so you already see that there may be a problem with this, but price is supposed to be a float. But it gives you a picture of all the data types for each of the column. Let's also check something here. Okay, we've done data types. We can look at the columns. Let's look at the columns. What are the columns within this data frame? df.columns, press enter. You can see all the different columns there. Kilometer driven, fuel type for this car, transmission, owner type, or not. So you can see the columns of this data frame with this. Okay. Any questions so far? Any comments or questions? Okay. Now,
I want to ask,
yeah.
how were you able to get the parts to the part that you need?
Oh, sorry, it wasn't clear. What did you say?
Okay, I'm asking that the parts. How were you able to get the parts of the file that you loaded? The CSV file.
I was able to get this file.
The parts. You know when you did when you did your pandas read, when we read there, yeah, so I'm talking about the parts. Okay. So like
Okay.
yes, the part to because sometimes if it's not there, I don't know.
Yeah. Okay. So for me, like this CSV file is in my the part where I have the Python notebook, right? But if you don't have the part of the, if it's your notebook is not directly on the part where you have the data, then you have to copy the parts, right? You have to copy the part of that file and let me see and use it there. You just copy the file, maybe c.user, whatever there. If that's your local system, then you just copy the file, copy the part and paste it there. Okay?
Okay, sir, yes.
Yeah, so that would work.
So what does that DF stand for? Is it defined or what?
Okay, who's asking the question now?
So is it fine?
Okay. So no, DF, we said DF, we just use it to call it's data frame. It doesn't see there, it's just data frame. So data frame, right? So data frame DF. Okay. So what we are doing here, we're loading this CSV file into this variable called data frame, DF. You can call it anything, like I say, you can call it used cars. But instead of us to be typing used cars every time, you just have DF. You can call it anything. Is it clear?
Okay, sir.
Yeah. Okay, so we're making progress. I hope this will be clear. Let me see. Okay, let me zoom in more. Okay, so so we've checked the columns. So now there are other things you can do, of course, to just get familiar with your data. Okay. The other things you can do, you can let me see. You can do like before we go into this, we can check like let's do something like info. Let's check the info data in df.info. So I want to check info about the columns within the data. So if you do df.info, you can see the number of non-null values. That's the values that are not NA. Let me show you what NA is. You see, okay, this will not help too much. You see NA here, it's not a number, like it's non-values. So non-values are null values, that means there's no entry there, right? Say there's no entry, you would know how many rows do not have entry from this count. So Pandas is giving you more details about each column. So if you look at, I think we have about 7,253 rows. These rows are complete, but if you go down, you see like this is not up to 7,253. So there are some missing values here. There are some missing values here, and there are some missing values here. There are some missing values here also, right? It looks like this new price has the most number of missing values. Okay. Please 1 minute. Let me get my charger. And you know this thing's off. Okay. So let's continue. So we see this row has less what do you call it now? Less number of rows that are non-null. Let's see something else. So let's take let's say the name, let's take name column, right? We've seen the different columns within our data now. So let's take the name column. So if you want to call a column within the data frame, you use square brackets. You see the different columns here already. This is what Colab is showing you. So let's say we use name. You have to put it in. You can call it like this. Then you can check for the number of unique value, n unique. I say don't bother about cramming these things. Once you start using them, you will get familiar with it. When you start coding, you will get familiar with it. Don't bother much. So check for number of unique values. Let me write it another way. Sometimes you can do df dot the name dot. So I use, instead of putting the name in comma, in these inverted commas, we can just call it dot name. Then look at the number of unique values. So n unique is giving us the number of unique values of this column. If you go back to the column, you see names of cars: Hyundai, Grand i10, Hyundai, Aeon, Delight, Volkswagen, Polo GT. So all of these names, it's telling us that there are 2,000 unique names out of these 7,253 rows, right? So it's saying there are 2,000 unique names. So if you want to list that, it may take, I'm not sure, Python will not show all of the values. Let's say we do name. Let's say what are these unique values. So if you want to look at what are these unique values, just use the keyword unique. The method unique will give you these unique values, but Python will not list everything. So just put ... then it shows the first, I think the first 3 values there and the last 3 values, right? So, but I think location is just, I think the number of unique values in location, let's see that. I like to do this sometimes. The number of unique values in location, number of unique values. So the number of unique values in location is 11. So we can list that to check the unique values there. We can list that for Python. We can list that for location. So we see it looks like an Indian territory: Mumbai, Kolkata, Delhi, Bangalore, Hyderabad, all of these different places in India, right? Now, I really wish I could get a very clean data from the Nigerian stats platform. I was checking for some, but maybe for the project we may get some, but it wasn't too clear to use in explaining these things. Yeah, the data did not come out too well, but they have very good visualization and they are doing a very good job too. Shout out to the Nigerian stats team. Yeah, so if you just put number of unique if you put df.n unique, it's going to show the number of unique values for each of the rows there, each of the columns rather. So you see for all of the columns, foil type has just 5. Let's see the different type of foil type actually. Let's see the different type of foil type. Foil type, let's see. Let's see the unique. So some of the cars use natural gas, some of the cars use diesel or liquefied gas, petrol, some are even electric. So 5 fuel types. What would be the different type of transmission? Can anyone guess? Different type of transmission. What would be the different type of transmission here? Can anyone guess?
Automatic.
Good. So it's either automatic or manual. So the transmission, thank you. The transmission can either be automatic or manual. Let's see that. Unique. Yeah. So when you're doing this, you're getting familiar with the data. You're getting information about what this data tells you about different car products, right? So let's look at missing values. So sometimes you can check the missing values between your data to see if there are some rows that you should take out, or if there are some missing values that you should handle. So if you do this is null values, so this is null tells us, let me do is null first before I add it. So if you do is null, you're going to see all of the rows, going to say, okay, is this value null? It's not null, so you put false. It's not null, it's put false. Not null, it put false. When it sees a null value, which is that none we're seeing just now, if you put true there, true. Then if you see that, then when you sum it, you're now going to get the summation of, so Python would look at, I think generally programming languages, false is like 0 and true is like 1. So it's binary. False is 0, true is 1. So when you add it, all the false values here will be 0. All the true values here will be 1, 1, 1 plus 1, 1, and all that. So if you sum that, you're going to get each of those values for all of the columns. So the serial number does not have any missing value. Name does not have any missing value. But new price here has about over 6,000 missing values. Out of 7,000, if this one has 6,000 missing values, it probably doesn't make sense. So this one has 1,000 missing values, but we could probably still manage that. If we check the percentage there, so the percentage is just, remember we talked about len, that you can use len to check the length of a variable. You can use len to check the length of a list or a data frame and all. So this is going to give us this summation all over. I think the length, we already know it's 7,000. Let's check it. Let's check it before we use it. So you check len here, len df. It's 7,253. So that's going to be, this is going to sum for each of the rows here, all the columns here. It's going to divide it by 7,253. You multiply that by 100, you get the percentage of missing values. Percentage of missing values within each column. So this one, the percentage there is 6,000 something, is 86%, right? So it has a lot of missing values there. Any questions or comments? Any questions or comments? Let's hear you. Any questions at this point? Okay.
Okay, so my question is, my name is Walter.
Yeah.
My question is, like what you are running now. Yesterday in the physical class, we are talking about NumPy and pandas.
Yes.
So the question now is, can this be run on NumPy, or is it being run on pandas? Which one is the best one to use? Because as it seems pandas how it's having more details than NumPy. So please, I want you to expatiate. Thank you.
Okay, sure. Good question. So pandas is mainly for data analysis, which is what we are using now. NumPy is mainly for mathematical operations, like you have an array of numbers and you want to maybe sum them or do inverse or store some mathematical values. You can sort them, though you can also do that in pandas. So now the thing is, NumPy is faster than pandas because pandas is built on top of NumPy. So pandas using NumPy for most of its operations, right? So pandas may be slower for some things, but pandas gives you a lot of functions to just do things easily, right? To just do things easily. So and then with pandas, your data is more organized. You can see, like with NumPy now, it may not be easy to even NumPy does not load CSV, for example. NumPy cannot read CSV. You may not be able to visualize your data like this, like you do in pandas, right? I have this experience that I was working on a project where I used a lot of pandas for the analysis of the data in the model we deployed. Everything looked good, but then it was really slow. And I now had to do extra work to find some place where we can use NumPy for some of the math operations, some of the storing of the data and then pushing that to the database. Yeah, sometimes, for example, like NumPy sorting may be faster than pandas sorting. Yeah, but there are some things that NumPy cannot do that pandas can do, while there are some things that both of them can do. So as you progress, as you get your experience, you would understand which one to use depending on the use case, or depending on the problem you're trying to solve. Yeah.
Okay, sir. Let me sharply add this little question. That means is it good for one to concentrate on pandas, and since pandas can do both what NumPy can do, so is there any case where one must use NumPy? Sorry for this question.
Okay, that's fine. No, it's okay. Like I think as you progress, first you should, I don't want to say prioritize learning one above the other, right? But most times for machine learning, you would use pandas more often, most times. But you may encounter, like I said, I encountered the case where I had to use NumPy to fast track some computations, right? So usually you would use pandas, use pandas for data analysis. So depending on what problem you are trying to solve, just learn the pandas or the NumPy, depending on the problem you are trying to solve, right? So if you like when we start saying, okay, you start working on your project, you're going to get data in CSV. You can't use NumPy to do that, to load the data to your Python. You have to use pandas to load the data. Well, there may be a way to use NumPy, but it may be very hard or may be very difficult to do that. NumPy is fast also because it stores data of similar data types. You can see that pandas, you can store integer with string, with float. All of them they just have their own columns, right? But if you want to do this with NumPy, you may have to do some extra work to create a structured NumPy array. So I'll say just learn pandas first, learn basic NumPy, but as time progresses, if you have to, it's like you say, it's Kaizen. It's a Japanese word for continuous improvement. It's continuous improvement. don't as the case determines, just learn the one you have to learn. So yeah, that's what I would say. So yeah.
So,
Okay.
I have
Yes.
a question.
Yes, go ahead, please.
Is there any other way to do that percentage of is null?
This one?
Yes, sir. Is there any other way to do the percentage?
There may be different ways though. There may be other ways to do it. Yeah. Yeah, there may be. I'm not sure. I'm not sure. This is like the easiest way I can think of now, but there may be other ways to do it for sure.
Okay, sir.
Yeah, there may be other ways. You know, Python is like that. There can be many ways to skin the rat. Yeah. But I can't think of any easy function now that you just call and it will do create all this for you. So that's why I think from the blog, because this I think I'll share the link of the blog for you guys to go through in more detail. From the blog where I got this data, this is the approach. Yeah, but there may be other ways to do it for sure.
Hello.
Yes, please.
I want to know why are you using the open bracket in some cases and you're not using it for some command. I don't know when to use and when not to use. Like data frame.add, you use the open bracket, but data frame.data type, you didn't use it. So when are we
Okay.
to use?
Okay. Yeah, so we talked about this one class that so this is a method within pandas, right? So when you have to use brackets, you will know that okay, you're trying to work on your data to get some information about all of your data, right? But if you usually if you don't put not usually, you don't put brackets when you are calling an attribute of pandas. You're calling an attribute of that data. So the attribute is we're trying to just check for the data types. You don't put brackets when you're trying to check for the shape of the data frame, when you're trying to check for the columns of the data frame, right? So when you're just trying to get attributes of your data, of the data frame rather, basic attributes of data frame, you don't put curly brackets. But when you're trying to do a method to perform some operation on the data frame, to load some data table or something, then you have to use a method which called bracket. But like I said, you don't have to bother much about learning if it's bracket. Just use it. When you're using that, as time goes, you will now know the difference. Okay?
Okay, sir.
Yeah. Yeah, don't cram it more. Just understand what the things that we're saying does. When you understand it, then at the time you can even ask Google, say, oh, I want to find a code to drop some columns. Then Google will give you. But if you don't know that, oh, there's a way to drop column in the first place, like you won't even know what to ask. Okay, so let's move on with the time that we have. So next step now, we've gotten some basic understanding of our data. We've gotten some basic understanding of our data. We've got some basic understanding for our data. So now I want to do maybe some data cleaning, right? There's some basic data cleaning though. If you look at the data here, we already identified some things that we may need to clean. That this new price, it just looks like, wow, no number, it doesn't make sense, right? Somebody look at this and tell me, okay, what other thing do you think we can clean from this data? There's serial number column, there's name column, there's location year column. What other thing do you think, okay, maybe we can use it, we may not use it, or what other thing do you think we can do here?
Location cleaning.
Okay, location cleaning, okay.
Or cleaning of the name column. The numbering of the name. Like 0, 1, 2, 3, 4. Cleaning that since we have serial number already, there's no need for that.
This serial number,
Yes. for name, since we have serial number, we have 0011. I think one is okay.
Yeah, exactly. Okay, thank you. So we need to take out this serial number because it doesn't add any value. It's just serial number. You can't use it for predicting anything on this table, right? 0, 1, there are unique values for every row. And you already have that numbering for this, so you can just take that out. Any other thing anyone can see? Okay, maybe it may not be obvious now. Okay, let's continue. I think that's okay. So we can drop those columns, the serial number column, because it doesn't add any value. Then we can drop this new price column. Sorry. We can drop this new price column because it has a lot of missing values there. A lot of missing values, lots. So if you run that, you'll see that we drop it, then we assign that back to the data frame. We check, you see that the new price and the serial number column are all gone now. It's gone. Okay. Okay, another thing we can do here, now, let's check for the name column and see the unique values. We already checked this before, and we said that the name column had about 2,000, over 2,000 unique values. Whereas if you check it, you can see that there are many Maruti products, right? Different model, wagon, Maruti products, different model, Ertiga. There are many Honda products, different models, Hyundai product, different model. So we can based on that, we can sort of split that table. We can split this name table to get the Maruti as a brand, then this other part of this as the model, right? Wagon Arrow or Creta 1.6, any other. So we just split this name to get more columns here. What other thing can we do? We can convert this here. Okay, okay. Okay, so let's split the model and brand. Let's split the model and brand first. If you check the model, let's see that. If you check the name of the model, value count, you would see Mahindra, Maruti, different kind of Maruti. There are also different kind of Hyundai. So we're going to split that. Usually to split, let's apply, like we said, you can call the name here with this df.name. Then let's split it. So this is how you split. If you want to split a text column, you call the string, I think a string method in Python, right? See, there's a string method, then this split. So it will split the string to different parts. Let's see what it does here. So you see it split Maruti, then the next part of Maruti is wagon, arrow, LX. It just split it with space. So the default is to split it with, anywhere it sees space, it just splits that to the different part. Creta 1.6, Honda, Jazz, all of these different things, right? But we want to create, let me see. Sorry. We want to get the brand name. So this brand name would pick just the first name here, Hyundai, Honda, and all of these things. So you're going to get the brand. Then we also do that to get just something that would help us know the model. We can combine the next two parts of the splitting. So that's how we combine it there. So we'll get the model. Then if you check that now, you'll see we now have more. This is a part of feature engineering. So we're trying to create some features to help us improve our predictions better. Usually, if you have too many unique values, like in that serial number just now, we just had 1, 1. We had the same number of rows as unique values, so that didn't make sense. You can't use that for prediction. But this name also has a lot of unique values. In many situations, it will not add much value in prediction, right? But now we can split it to brand. So let's see how many unique values brand has now. the brand now has about 33 values. So this can make some sense and help in prediction. Can make some sense and help in prediction. Then you can look at the unique values here: Maruti, Hyundai, Honda, Tata, Land. Okay. Okay, we're seeing some issues here already, right? Okay, what are some issues that you can see from these names of the brands?
The same name, but different cap.
Yeah.
Different case, like Isuzu. So
Okay, Isuzu. Yeah, thank you, Isuzu. Okay. I don't. I'm sorry. Let me just pause for a bit. I'm trying to get your. I don't know the. I don't have the attendance list. Let me just check quickly. Let me just check for the attendance. Oh, man. Okay. Okay, so for those asking for attendance, this is your attendance list. This is your attendance. So you can use that, but try to still stay in the class to the end. Okay. All right. So let's go. So someone said Isuzu, yes. Okay, Isuzu. Well, if you don't know customer, you may not be able to spot the other ones. Like me, frankly, I didn't really know that. Okay, Mini was a Mini Cooper. Then a Land doesn't make sense. It's actually Land Cruiser. So we're able to update those names within a particular brand, within a column. So you can use replace keyword, the replace method. So the replace method, you can pass the items that you want to replace. So want to replace this capital letter Isuzu with Isuzu. Want to replace Mini with Mini Cooper and Land with Land Rover. The input in place equals true, it just does it on the same data frame. Another thing that sometimes you can do is just to turn everything to small letters. You just make everything to be in small letters, but we're not doing that for this, right? Then if you check now, am I even running all this? Okay, let me run this one. So if you check now, you can see, let's see the brand. Let's see the brand unique values now. Okay, is Isuzu correct now?
yes.
Okay. Okay. Let me just check. Okay. All right. So now we can check the data types if we need to convert anything, but it doesn't look like there's anything to convert here. If you check a data type and this is year, this is kilometer driven is integer, FOI type is objects, owner, all of the data types are correctly specified. But if you had a data type that was different, for example, then let's do this, but we'll not assign it to anything. Let's say we want to convert price. You can do this. Price will be, now want to perform a method, want to perform something on this data frame. So I want to change the type of this price. We're going to use as type. Then you specify what data type you want to use. We can say string. Want to turn it to a string. If you press enter, it will give you some values there, but these are strings, it's not object, right? So if you assign this to price, we put this into price, it's going to change the data type for price, but I don't want to do that now. Okay, so as type string would do that for us. Now, another thing that I want to do, we want to do some feature engineering here. Some feature engineering. Any questions so far? Any questions? Yeah? Okay, well, we're making progress. I hope that you can spend time later on this to understand more. And I hope we're not moving too fast for some people. Though some people feel are moving too slow. So so there's conflict of interest in that case? Okay, so some feature engineering here. So we want to instead of using the year, we want to use the age of the car. I want to know, okay, how old is this car? A car of 2010 is probably 14 years now. That can make more sense in modeling. Right? That can make more sense in modeling. So let's use year. Let's use the year. So if you want to use year in Python, I know initially we said you should load all your import statements at the beginning, but there are some times when you start working, you may not know what modules you will need. But as the case demands, you can import it at any time. So now we need a Python model, a Python package to know what is today's date. What is today's date? There may be different ways to do this in Python, but one easy way is just to use datetime.date. Then when you call the today method here, it's going to give you today's date. Let's check that. To give you today's date, right? Then if you take the year out of that date, you can take the year. Then to give you this year, to give you the year of today's date, 2024. So we can use that year to subtract all the years. Subtract all the years of all the car years, production year, I believe, from this data from today's date to get the car age. So now we're creating a new column again, a new column or a new feature. Can call it feature or column. Feature are like attributes of your data. So feature or column yeah, so if we create that, we're going to get the car age. So if you check now, you're going to see car age in our data, car age. So it's giving us the car age. 2010 is 14 years old car, 2015 is 9 years old car, 2011 is 13 years old car, and all. So we talked about exploratory data analysis, what it can do for you, to give you a clue into your data. So now we want to do, since we've done some cleaning, right? We now have some good data that we can use for further analysis. But mind you, there are sometimes, frankly, where you may have to do more cleaning than this. In fact, there was some cleaning I did on this used cars data. It may be a little complex, that's why I didn't share that, to get these used cars. Okay, so there may be more cleaning that you need to do, but when you see that you know how to handle it, you can just check Google or something to get more information about how you can use pandas in such cases. Okay, so let's go now to we talked about, we can look at some distribution of the numeric data by using describe. So the describe method would show you will show you some information about the data, right? So if you start with that, it just helps you see the distribution of your data. So if you just use describe.t, it's going to bring all of the numeric data, which is year, kilometer driven, car age, and all. Then it's going to show you the mean and minimum and all that. What can you see from this data? Is there anything that you can highlight? Let's do some activity now. Who's following? Following, what can you see? Is there anything you can highlight? Yes.
No, I mean, what's the question again?
What's this table here showing you? Is there anything that's obvious to you? Okay, let me pick one. Then maybe you get the other.
Standard deviation percentage.
Eh?
Mean standard deviation percentage.
Okay, good. So you see that the minimum year, this minimum is mean. So the minimum year is 1996 and the maximum year is 2019, right? So it's saying, okay, it looks like the cars that we have on this data, they range from cars produced in 1996 to 2019. And the average is made between around 2013 on average. The cars are made around 2013 on average. But the minimum and maximum is between 1996 to 2019. That's about, is it 23 years? Yeah, so we have car products that are made for over a span of 23 years. So you already get a sense that this data is across is it decades now? Decade is 10 or yeah,
Yes.
right? So it's across 2 decades. So there may be a lot of different like old products, new products, and all of that. So you already get a sense of that just looking at that first row. So what else can you see there? Just look at anyone and you can give your view.
You can see the percentage.
Okay.
So I can see, yeah, we can see that 50% were like 2014.
Okay. Okay.
Yeah, 60% 2014.
You can look at the other rows too.
Yeah, the other rows, listen. So I don't know the minimum number of seats here. I'm seeing 0.
Yeah, so maybe there's
Okay.
something wrong with that data because it's saying that the
No.
car doesn't have any seats.
No. There's no car that doesn't have a seat.
Because you have a driver now, so why would you not have a seat?
That's the meaning of the 0.
Yes, yes.
Yeah.
Yeah, so you're already seeing there's a problem with that. So maybe we'll delete rows where the seats have 0.
Okay. Can I talk on? Can I comment now on the
Yes,
observations?
continue. Yeah, for sure.
Car age. If we go to the car age, we'll see that on that minimum we have 5. That's car with 5 years. Then we have under 50%. That's 50% of the car are 10 years old.
Yeah.
And the same thing applicable to 75% and 35% respectively.
Good. Yeah, that's a good observation too. That the youngest car, though there's an, if you notice now, there's an inverse relationship between the year and the age year. That the youngest car is 5 years old, but the maximum, that's actually the maximum year, which is 2019, so 5. Then 1996 is the minimum year. That's the car that's 28 years old. Right. So about 25% of the cars, right? About 25% of the cars are 8 years and they're about 8 years old. Right. So about 25% of the cars are about 8 years or so. There will be cars that are probably higher than this, but above that is just 8 years the mark for the 25th. They call it 25th percentile also. The cars are equally above 10 years and below 10 years. That's 50% mark. The 50% mark or the average is 10 years. You see that matches with 2014 also. Then 75% of the cars are below 2016. So yeah, let's see.
I ask
some plots? Oh, it doesn't make sense.
Hello?
Okay, continue, please.
Yeah, up there, I'm seeing something. I want to comment because it's looking like, because if 75% of the cars are 13 years old, and then let's say 25, 50, and then 50, 10, 50. So I'm seeing that there might be outliers, a lot of outliers because of if the maximum is 20 years. Because if 75% of the whole this is just 13, so I'm saying from that 13 to 28, there might be some data that might be far away, like little of them that are outliers that might not be needed. Just based on what we
Yeah, good observation too. So with that, we would when we look at the data, yeah, you can see maybe this is for engine and power though. But when we look at the plots, you may be able to see more clearly columns that have more outliers. Right?
Right.
So we may be able to see more. So what the 25 like? Maybe let's see more observations here. Minimum mileage is 0. Looks like the engine and power of outliers. So the data is right skewed. So when we do plots, it may be more clear to you what those values may be. So really, this. Let me see if we can draw this. I think we drew before. Let me see. Okay. Okay, let's use this drawing here. So, like we said, if you have a distribution of the car years or age, right? This is the 50% mark, which is the average. Usually it's 50% of the cars are above this and below. So it's usually close to the average, but it's not necessarily the average. If you look at this, 50%, but the average is 2013, right? It's close to 2014 though. So it means that there are cars that are equally spaced between 50% and above this 50% mark. So 2014. Then the middle of this is now 25%. Right? 25%. So it's saying that there are some cars, 25% of the cars are below this mark of 2011. Right? They are below from 2011 down, and 75% of the cars are above 2011. Right? Then if you look at this, if you split here equally again, you get 75% mark. So 75% mark is saying, oh, there are some, about 75% of the cars are below this. Then there's another 25% that's above this value here. Okay? Does that make sense?
Yeah, yes.
Okay, okay, okay. So when we plot this thing to be more clear, I believe. Let me get this. Okay. So now we can, we talked about still have some time here. We talked about categorical variables and numerical variables. So you see how we are building on top of what we've learned. That's why we talked about data types last week. Now you now know let's recap. What are categorical variables and what are numerical variables? Can help us with that?
So I want to ask a question.
Numerical variables.
Yeah, let's
According to the name.
According to the name,
According to the name, numerical variables are variables with numerals, like maybe integers, any number.
Okay.
So I'm just using idea. I'm not very sure. But categorical variables would be maybe
Yeah,
variables with strings
but you tried,
or that are in the
yeah.
same category.
Yeah, yeah. Okay, you tried. Yeah. Thank you. Let's allow a lady speak too. It just occurred to me that no lady has spoken since over 1 hour now. Can a lady speak on behalf of the ladies in class? Yes, what are categorical and numerical variables? Or did I get it? Okay, if you have a question, ask. Let's not ask you tough questions. What's
So I want to ask a question from the data above there.
yeah.
The graph. From the graph, is it the system that generated the
Yes.
summary?
Yeah, just let me try this Google plots suggested chart, but it doesn't make sense. It it didn't make good sense of the data. So we will have other plots below. Yeah.
Okay, so the summary is generated like year range from 1996 to 2019 and a high in range which shows used cars. So is it the system that generated all this?
Which one? The used cars, the plot,
No,
or what?
this one, after the plot, it says from the statistics summary, we can infer the below findings. So who did the finding? Is it the system that generated that, or did you write it by yourself?
No, I put it down here.
Okay.
Yeah.
Okay.
Yeah, it's from the study where I got this. Yeah,
Okay.
and just looking at the data to you make the observation. It's not chat. This is not ChatGPT.
Okay.
ChatGPT can generate that, but it's not.
Okay, sir.
Yeah, yeah. Okay, so we said categorical. So you were right. I can't see your name now, but I saw user. So you were right about.
Gabriel, show a memo. Show a
Oh,
memo.
Gabriel.
Building
Okay,
Gabriel.
okay. The one that appeared twice on the list. Okay. Yeah.
Even 3 times. I don't know why, sir.
Yeah,
I
it's
saw one show a memo Gabriel on twice on one particular list. I saw another one show a memo Building Gabriel. My name is show a memo Building Gabriel. So
I think what happened is it's like you already put your name, then when I copied your name and added, so that's why it's double there. It should be one. Yeah. Okay, so this categorical variable will say that they are qualitative variables that do not necessarily have any mathematical meaning. So they're usually objects or strings in when you when you have your data, right? So this data are usually text strings that do not necessarily have any mathematical meaning, but they give you some information about your data. So we have to find a way to make use of them to get more understanding of our data. Numerical data makes quantitative data makes mathematical sense. You can use them for further analysis. So with Python, you can select the data types. You can select from the data frame, we're selecting data types. We want those data types to include just objects. Then we get the columns where these data types are in. That will give us the categorical columns. Then we are selecting data types to include np.number means either integer or float. So you see where we're using NumPy now. In all of these things that we've done, this is the first time we're using NumPy. So NumPy would help us get a function that represents either integer or float. And then we convert that to a list of columns. So if you see that here, maybe I should add to list to this one also, to list. So you see that there, it gives us a list of the columns that we are dealing with. So name is a categorical column, name of the car. Location is a categorical column. Fuel type, transmission, owner type, and all of that. Then the numerical columns are the year, kilometer driven, mileage, all of these things there. Yeah. So we want to do some visualizations now in Python, right? We want to do some visualizations. So we want to do, usually, like I said, if you have columns in your data like this, we have about 1, 2, 3, 4, about 11 columns we had. Let's use Python to check it. Let's not count. You can just do length of df.column. So that would tell us the length of the columns, 15 columns. So you have 15 columns in our data. Sometimes you may have to go through each of the data one by one to understand what's really within that data. Apart from the overview that we use to describe the data, you may have to go, okay, name. Let me see the types of names I have in this car. Location, what kind of locations are in this car? Which location is most popular here? Which location is least popular? You can look at the fuel type. Is it like most cars are just gas, or most of the cars are electric? So if you go through that, it gives you a sense of your data more and more. And as you learn more about the data, it will also help you to determine what model will be best for your kind of data. So mainly, sorry, let me just clean this Let's clean this. Yep. All right. So mainly you would use Seaborn. Seaborn is a Python library built on top of Matplotlib. Matplotlib is the main Python library for drawing charts. But Seaborn built on top of Matplotlib, and it makes you use like simple line of codes to plot very fine styled statistical plots from pandas or NumPy data. So you can do univariate analysis. Univariate analysis just means we're looking at each of the column one by one. Then we can also do multivariate analysis or bivariate analysis. So univariate is one variable, you're looking at column one by one, one. Bi, you're looking at two columns to see how they relate together. Then after bi, you can look at multivariate, which now you're now looking at how the multiple variables interact together. So categorical variables can be represented using like count plots or bar plots, right? So count plots are like you're just counting, okay, how many values of each of this each of the unique values within this column, how many are they? So you can do count plot, you can do bar chart and all of these different plots. Then numerical variables, you can look at histogram box plots. I think we'll have a box plot here. So box plot can help you see where there are outliers. What column has a lot of outliers there, right? Then yeah, so we'll do the univariate analysis first. So simple, I'm just going through the numerical columns first. So that's, we see if we did for loops before. So now we're using for loop.
Can you
Yeah.
first remove the underground noise? There is one person making noise here.
Okay, somebody just joined. Let's meet everybody. Okay. Okay, so we're using for loops now, you see. For loops, we've talked about for loops. We can print the column to see, okay, what data, print the column to know what particular column are we viewing here. Then we can print this queue. This queue tells us where the data is shifted to, whether the data is shifted to the right or shifted to the left. You'll see that from the histogram plot. So that year that we're talking about just now, that there may be outliers, you can see some outliers. Let's go back to this. So first we're going to plot two plots for each column. So we're going to plot the histogram plot. So histogram will tell us for each of the values within that data, maybe within a range, how many values do we have there? For each of the entries within that column, if I can use that, let's say every entry within that column for a particular range, how many are there? So it's like a frequency plot. That's histogram. Then box plot would plot the minimum, maximum, the percentile range or interquartile range. Then it will tell you, it will show some values that are outside that range. So that would usually give you an idea if there's an outlier or not, though not every time that those values are outliers. So let's see the plots that we have. Say we're plotting just histogram and box plot for each column. So if you look at this one here, you can see that it has more, we have more values to the right here. We have more values to the right here. We have more, like we're saying just now, about just 25% of the data was below 2011. 25% of the data is below 2011, right? And we can see that the histogram just shows us that nicely. While once you go further to about 2016, you see that 75% of the data is already covered and only 25% of the data is after 2016. Then if you go to the right and you see the box plot for the year, you already see some like outliers, all those what do you call them now? old model cars, like old model cars, old model cars. All those old cars that they are just few years. There's some of them outside this range of the minimum, maximum, the average value here, average around 2014, right? Then the 75th percentile, 2016. This is the 25th percentile, which is 2011. Then minimum, maximum, we see that, yeah. No, I'm not sure this minimum, maximum. This 2019. The minimum was 1996. So this data is an outlier. This data outliers. This is about 2004. This is about 2004. Let me see. Okay, let's go to the next ones first. So this does not make much sense. Kilometers driven. Oh, let's pause here. Let's take a breather. Any questions so far? Any questions?
Hello?
Yes, please.
That point where you were trying to explain in between 2010 and 2015, that point is the minimum that we did. That's 2014, 20, yes, that point there.
This
2000,
point?
yes, 2004. If we go back to the distance, you'll see it there.
The minimum is 2004. The minimum was 1996. Yeah.
Okay.
Yeah, it's 1996. I think it's the interquartile range. So the minimum was 1996.
Nice.
Yeah. So this 25% is 2011. Yeah. Okay. So yeah, the minimum was 1996. That's this one, right?
Yeah.
But there's something called like interquartile range. So like if you multiply, let's say if you multiply this by what this 75th percentile multiply by 1.5, then this by 1.5 or 2.5 or something. So they multiply this by a particular value here, maybe with the mean divided by standard deviation, or let's not go into much of the maths, but there's a range that we have here that when values lie outside that range, it gives us an idea that these values may be outliers. So that's mainly what you use a box plot for. So you have all the percentiles that we saw, then the mean, then there's some interquartile range here, then values that lie outside of that, we can call them outliers. Okay, so just now we're just looking at the data of the year. We got some idea that there may be some outliers already just by looking at the data and understanding the 25th and 75th percentile ranges. Then for mileage, the mileage seems to be fair. It looks fairly distributed, though there are still some small outliers there. So just some few outliers there that we can see outside that range again. That's what a box plot does. But we see that it's almost evenly distributed across the average. This looks like the average, and it looks like it's just equally distributed there. So this is seat number, just a few values there. 0, I don't know where 0 came from. Some cars have just 2 seats. So there are sometimes when box plots may not give you very interesting things to look at, right? But histogram can, of course. You see that this car age here is opposite of the year, right? You know why that is? You understand why the car age is like inverse of the year? Because the higher the year, the younger the higher the year, the younger the car is, right?
Okay.
Is it clear? Is that clear? That if a car like the year, they say the car is 2019, that means the car is just 5 years old. But if the car is if it's 1996, which is low, that means the car is about 28 years old. So that's why there's an inverse relationship between the car age and the year. Okay, let's go further. Price and kilometers driven are right skewed. You can see the price here. It's right skewed. So this will be positive. Okay. So there are some other plots though, some other plots. The plots of, so you see that the plot that we're using now for categorical variables is the count plot, SNS, Seaborn. So we're using that to look at fuel type, the categorical variable transmission. So there are just some, you don't need to bother about this. You may not, like when you're doing this usually, if you want to plot count plots, well, I've not been plotting for a while now, but I still do it occasionally when I'm plotting. Like you just carefully ask Google how to plot count plot with SNS, and you will see a lot of recommendations. But at least you should know what you're trying to get. You want to plot the count plots to just review, to just see the distribution of the data, the categories. Let's see the fuel type. Let's see the foil type. So if you look at the foil type here, this makes more sense for us. The foil type shows that a lot of the cars are still petrol and diesel. Most of them are diesel cars. Wow. Most of them are diesel cars. While there are just a few gas cars here, CNG and LPG, and just a few electric, maybe like 1 or 2 7. Most of the cars are manual. You can just see the counts already. Manual, about 5,000 of them are manual, while about 2,000 are automatic. Wow. So older cars, because I think they are more older cars, right? So maybe more of them are manual than new cars automatic. Okay. Owner type, first owners, most of them are brand new cars, you still own them, first owners. So most of those old cars are the first owners, second owners, like that. Then most of the cars are in Mumbai. I think, I don't know, is it Mumbai that's the capital of India? Hyderabad is also a popular city in India. So most of the cars are in Mumbai, Hyderabad also. Okay. Most of the cars are, I think Hyundai, is it Hyundai? Hyundai, they call it, is it a South Korean car, Indian car? Tata is an Indian product. Why is it not popular there? Okay, so you're just looking at your data, you look at the plots and you're getting some information about all of this. Like let's say if a business, right? If you were to be a salesperson or a business person and you see that it looks like a lot of cars sell more in Mumbai. So you can talk with the director in Mumbai, or you can try to get more information about Mumbai. How can we sell more cars there? It seems like people are interested in our cars. Then Ahmedabad, why are people not buying our cars? Then let's go and find out what's going on. Why are people not buying cars? Either their income is low and they can't buy our cars, maybe our cars. So some of this, if you just look at that data, you can start making business decisions already from just getting insights from looking at your data. So these are some of the outcomes that you can infer from just looking at the data there.
Now, can you help us to mute everybody again? There is underground noise interrupting with what you are teaching us.
Oh my God. Oh my. I don't know why people do that. Okay, so let's wrap it up around there. Let's wrap it up. I'll share this notebook. It will also be on the Google Drive. You can go through it. And then I think I'll share the link where you can also go through some more. Though we've touched on everything on that blog post, but you can go through the blog post to just get some understanding about this. Okay, so now pair plot would give us correlations. We said correlations gives us an idea about if a data is moving in a similar direction or moving in opposite directions, or there's no relationship at all, right? If you just look at the pair plot here, this SNS is giving us some nice pair plots. I don't think I should remove let me not remove the let me remove this drop statement here, please. Let me just remove this. Sorry. Let me just remove this. It takes some time to plot it though. Does it even plot to categorical variables? It's plotting for all the columns related to each other. So that's why it's taking some time, right? So we can look at that to understand some of the correlations within our data, just looking at how the data moves, right? We can see, if you just look at this, as you scroll down, you can quickly just see that it looks like these two things are moving in the same direction, these two things. If you go to the left, you will see that in power. If you come down, you will see the other out in engine. So the power and the engine, right? The engine and power, even obvious from the name, they move in similar direction. They have a strong correlation there. If you look at engine and I think power, okay, engine and power, just the same thing there, moves in similar direction. Let's see if there's any other thing. What a price. Okay, year and car age. We've already noticed that from the previous analysis we've been doing. They move in inverse direction. Their correlation there is negative. Let me see. Is there any other thing you find interesting here? Oh, kilometers driven and year. Nothing there. It's just flat. Well, the kilometers driven, another thing. Okay. Maybe we'll talk about that later. So let's just wrap up with this. We can also look at the correlation in terms of not just looking at the plots now, but looking at it in terms of values. With a heat map, you can just see the correlations of, we already noticed that power and engine have strong correlation. We can see that here, 0.86. Power and engine is 0.86. We can see negative correlation between power also and mileage. Most cars that have, maybe they have when they have driven it a lot, a high mileage, maybe the power of the car drops or something. Or maybe cars that they drive a lot, they don't have high power. So because most of the cars are old anyway, so maybe that's why. Then we can see price and power have good correlation here. Let's see it on this SNS plot. Price and power. Price and power. Look at the correlation here. Okay, we didn't notice that just now. Price and power, then price and engine also. So when the engine, okay, it's obvious now. When the car has a very high power rating, then the price will be high, of course. So that's why this. So this heat map is giving us a figure for the correlation value. So it makes it more clear, obvious when we see correlation. So if for example we are building models to predict price for this with this data, we will know that some key variables that you should use for predicting would be, of course, power, engine, there would be some good indicators of the price. Though it doesn't mean that mileage will not work because this is negative, but it will still work. It doesn't mean the other ones will not work. It just means that these ones that move in the same direction sometimes may have a stronger relationship in predicting this particular value there. Okay, so see the highlights here of the major things you can infer. So any questions, any comment? Let's wrap up. So there are sometimes, I was going to say something that I said maybe we'll talk about it later on. There are sometimes when, if you have values that are different scale, like this kilometers driven, it doesn't make sense much for us because it's a very high value. Let me just open that. Let me just, if you look at DF dot here, let's look at it. So you see kilometers driven is 72,000. Imagine comparing 72,000 to 26 to, what's the price? Okay. Price 1.75. It's like the price even in millions. So sometimes you may have different scales for different numeric values, but you can do what they call min-max scaling. We can use scaling to bring the numeric values to be in the same scale. So we're going to see that when we start modeling next week. So this is me concluding the class. If you have any questions now, you can ask. Next week, we're going to supervised learning proper. Maybe we'll use this data for our first prediction. Yes, any comments or questions?
Hello, thank you, sir. I don't really have a question. What I just want to suggest that you could help for I want you to help us to be dropping the record as quick as possible so that we can go over it again and again. Rather than when it is close to the next class, maybe 2, 3 days to the next class, that is when you'll be getting the record. If possible, we can get it in that same day or latest the following day, latest next
Okay.
day. It will be better, please. Because some of
Okay.
us don't have that time to study when they drop it. Because
Yeah. Can you see this? Let me see. Can you see this? Can you see this page?
yes, sir.
So I think I've shared this link with everyone. I think I've shared this link with you. So, okay. Wait, I think we'll just we'll pause recording maybe because some of these other things that we're talking about are not related to the class. So I'll just stop sharing at this point. I'll just stop the recording at this point. Okay. All right. Are there any questions related to the class? Are there any
Yes,
questions
sir.
related?
I have a
Yeah,
question, sir.
related to this we just studied.
Yes, sir. Yes, sir.
Okay.
I want to know which of the libraries is involved in is responsible for the plotting of those graphs, especially the heat map.
Yeah, okay. So it's this Seaborn. So we imported Seaborn as SNS, right? So it's
Okay.
Seaborn that's responsible for that. So if you see the heat map there, we just say SNS.heatmap. Yeah, if you want to do this in Matplotlib now, you may need to put a lot of coding, a lot of, assign annotate this and that, but you just do it easily with one method in SNS, heatmap. Okay, so it's Seaborn.
Okay, sir.
Yeah, any other question there?
Even the match plot slip was possible because you said you have to have before we have the Seaborn. If you want to use the Seaborn, the question was just asked now. I mean
Sorry,
to import the
come
match.
closer to your network. I could not hear you well. Start, please. You
I said
said?
I want to import the match plot slip first, importing the Seaborn before we can use it. According to what you said earlier.
Yes. So you import Matplotlib, but Seaborn is built on top of Matplotlib,
Yes, that is what
right?
I'm saying. There is any need to in smart plus leap first. Calling the Seaborn to have your sort that.
Necessarily, is all anyone that import first is okay. Let's even wait. Let's create a new notebook. Let's even check something. Obviously, we'll not close this one that we're working on now. Okay. What's going on here? Sorry. I want to open a new notebook. Okay. So let's do import Seaborn as SNS. I just want to try, let's just quick one. Okay, let's import pandas. So let's read that data again. Okay. Set index call equal to 0. So let's do the heat map. Oh, I don't know if the heat map will work with this. If I'm not done all the data cleaning we did before, but let's try. Data equals df dot is equal. We have to create the correlations. So you see that you have to check these things. So we have to take the correlations. Then we have to use annotate equals true so that it will put the number on top of the map. So let's see. Yeah, so it works even without matplotlib actually.
Okay.
So you see, so because Seaborn works on top of matplotlib, but Seaborn automatically imports matplotlib with it. Yeah, yeah. It's just like pandas works with NumPy, but you can import pandas and you don't have to import NumPy. I just wanted to be sure. Yeah, I know it works. You don't, it's not compulsory to import matplotlib actually. Okay.
Yes, sir. Thanks.
Yeah. Okay, any other question related to the teaching? Okay, so I'll just add this part also that please, for the group leaders, I don't know, I'll see announce it on the chat. Let's connect on calendar. Let me see if this still works. So I want to have I'm free this Monday. I'm not too free, but we have a public holiday on Monday. So I want to meet with the team leaders. We'll still schedule some subsequent meeting, but let's meet this Monday to decide your project so that you guys can start working on the project. It's just to come here and schedule a 30 minutes meeting. You'll see some slots. I think I didn't put Monday before, but I'll open up Monday here so that we can have a discussion for, I think we should meet group by group, not I want everyone to just come together and meet, but that would be too much. Let's just meet group by group. No, let's meet each group leader one by one. Or meet each team. Sorry, you come with your members of the group, then we'll meet. So I've also joined the group chat within each of the groups so that we can start having a conversation about the project. Let's see what we can work on between a month. I think we just have about a month and some days now. Yeah, but at least we've set the foundation for data analytics and machine learning already. Next week we'll start modeling. Before some people chase us out of 3MTT. Okay, so I'm going to stop recording now. I think we've yeah, I'm going to stop recording.